In each of these examples, we're trying to find the slope, distance, and midpoint. So there's a formula for each one. So let's just talk about slope first. So the slope formula is m equals y2 minus y1 over x2 minus x1. So we're given two ordered pairs here. What I'm going to do is go through and label them as my 1's and my 2's. So it doesn't matter which one is which. I'm just going to label that my first point is x1, y1, and my second point is x2, y2. So now all I'm going to do is take these numbers and I'm going to plug them in where those letters are in my formula. So my slope for this first example, I would do y2, which is -7, minus y1, which is 1, and that's over x2, which is 2, minus x1, which is -4. So I have a minus that's part of the formula, and then I also have a negative that's in front of my 4. So there's going to be a double negative there. Now I have to simplify and reduce. -7 minus 1 is -8. 2 minus -4 is actually 2 plus 4, which is 6. So I'm going to have a negative answer here. I can divide both 8 and 6 by 2. So that would reduce my final answer to -4/3. So that would be the slope of the line that goes between those 2 points. Now let's do the same thing with problem 2. So I'm going to label my points x1, y1, x2, y2. And again, it does not matter which point you decide to make the 1's or the 2's, as long as you're consistent. For my slope, I would do y2, which is 6, minus y1, which is -3, so I've got that double negative thing happening again, over x2, which is 2, minus x1, which is also 2. 6 minus -3 is 9, because it's actually 6 plus 3. And 2 minus 2 is 0. So something kind of strange is happening here. It is not allowed to divide by 0. You can't take something and divide it into nothing parts. So when you have this situation where you end up dividing by 0, what this means is that your slope is undefined. And you might remember from algebra that when you have something, a line that has an undefined slope, it means that it's a vertical line. So you can think of it as like a hill. If you're on an incline or if it's just flat, that would be your slope of 0. If it's just like a straight up and down, that would be like a cliff. You can't walk on that, so it doesn't have a slope. Okay, now let's talk about distance. Distance, again, has a formula. So I'm going to do everything for distance in blue, and I'm going to write the formula over to the side. This one is a longer formula. So the formula looks like this. D equals, and then this really big square root. Inside the square root, you'd have in parentheses x2 minus x1 squared plus y2 minus y1 squared. So I already have my points labeled x1 and y1, x2, y2. So I'm not going to change any of those labels because I'll just use the same points. All right, so for distance, for first example, we're going to plug some of these numbers in, and this is going to get a little cramped because we're going to do a bunch of work here. So x2 minus x1 would be 2 minus -4, so 2 minus -4 squared. And then I would have y2 minus y1, so that would be -7 minus 1 squared. And what you might notice is that 2 minus -4 is the same thing that we got in our slope formula, and also that -7 minus 1 is the same thing we got in our slope formula. And that is not a coincidence. It's because if you look at our formulas, this right here, the x2 minus x1, which is the denominator of your slope formula, is the first parentheses in your distance formula, and the numerator of the slope formula is the second parentheses. So they are the same thing. You're going to get the same numbers when we simplify, but then the formula is going to take over and it'll be, a different answer. Okay, so 2 minus -4, if I change those both to positive signs, is 6. So I'm just going to write that down here, 6 squared, and I'm going to put parentheses around it. And then -7 minus 1 is -8, and we're going to square it. Now when you square a negative number or a positive number, you're always multiplying that number by itself. that means that no matter what the sign is, our answer will always be positive. So what we're going to end up with is going to look like this. 6 squared is 36. Negative 8 squared, is positive 64. And then if I add those two things together, that gives me 100. And the square root of 100 is 10. So that means that these 2 points are 10 units apart from each other. All right, let's talk about the distance for problem 2. Again, I already have my labels done, so I'm just going to start plugging them right into my distance formula. So I have d equals, and then I have this really big square root. x2 minus x1 would be 2 minus 2 squared, of course. And then in my second set of parentheses, I would have 6 minus negative 3 squared. And again, those values are the same. So the 2 minus 2 is the same as this, and the 6 minus negative 3 is the same as this. So this would turn into 0 squared, and 6 minus negative 3 is actually 6 plus 3, which is 9 squared. So now over here, 0 squared is just 0, 9 squared is 81. 0 plus 81 is 81, and the square root of that is exactly 9. So that means these 2 points are 9 units apart. All right, now the last thing is midpoint. Midpoint is going to be a point, and it would be the point exactly in between or in the middle of the 2 points that we were given. So the formula looks like this. It's x1 plus x2 over 2, comma, y1 plus y2 over 2. So midpoint is actually a point, whereas slope and distance were just giving us one number. Midpoint will actually give us an ordered pair. So again, my numbers are already labeled. I'm just going to plug them in. So for midpoint of problem number 1, I would take x1, which is negative 4, plus x2, which is 2, and divide it by 2. And then I would take y1 plus y2 and divide it by 2. So that would be 1 plus negative 7 over 2. So that double negative thing now isn't going to happen anymore because we don't have a negative as part of our formula. Now all I have to do is simplify. So negative 4 plus 2 is negative 2. 1 plus negative 7 is negative 6. And then if I divide these, negative 2 divided by 2 is negative 1. Negative 6 divided by 2 is negative 3. So my midpoint, which is the point that would be exactly in the middle between my original points, P and Q, is negative 1, negative 3. All right, let's do the same thing with number 2, and then we'll be done. So I'm going to plug my numbers in. So my x1 plus x2 would be 2 plus 2. And then y1 plus y2 would be negative 3 plus 6. And if everything is divided by 2, that's part of our formula. 2 plus 2 is 4. Negative 3 plus 6 is 3. And then when I simplify, 4 divided by 2 is 2. 3 divided by 2 doesn't come out to a whole number. So you could either leave it as 3 divided by 2, or you could write it as 1.5. I think decimals make a little bit more sense, especially when you're trying to imagine where you would plot a point.